Okay, let's give you guys some more practice. So here, find the quadratic approximation for f of x equals x plus 1 to the power of 3 near x equals 0. So x equals 0 is here. So you got to find out the quadratic approximation. So your quadratic might look something like this. Okay. So anyway, press pause and have a go. Okay, so to do this here, start out with your quadratic. So your quadratic will be in this form here. This is your original function here. So your quadratic is here. Your original function is this one here. So now the first thing to do, look at the value at x equals 0. So put 0 into here, and then well, when you put 0 into here, these two will get killed off, leaving you c. And then when you evaluate this at x equals 0, this whole thing here will be 1. So now you know that c here is 1. Okay, now we've got to find b and a here. So the next step is to look at the first derivative of our quadratic and look at the first derivative of our original function, and then set the two first derivatives to be the same. So hang on. So our original quadratic here, differentiate it will give us this. Okay, our original function here, differentiate it will give us this. Now somehow create our quadratic in such a way that the first derivative of our quadratic will be the same as the first derivative of our original function here. Okay, of our derivative of the original function. Okay, so put 0 into here. So that will then, this will get killed off, leaving you b. Okay, now put 0 into here. This whole thing here, when you put 0 into here, this whole thing here will be 3. So looking at this bit here, it's saying that the gradient at our original the gradient the gradient of our original function at x equals 0 is 3. So we want to do the same for our quadratic. We want to get our gradient of our quadratic to be the same as the gradient of the original function at x equals 0. So basically set this to be the same as this. So now we know our b. So earlier c was 1, b here is 3. Now we've got to find out a. So the trick to finding out a is to look at the second derivative. So now this here is our first derivative. Differentiate it will give us the second derivative. Looking at the original function, this is the second. This is the first derivative. Differentiate it will give us our second derivative. Now we are trying to evaluate it at x equals 0. So put 0 into here. Then the second derivative will be this. And looking at our original function, the second derivative at x equals 0 here, this whole thing. So the second derivative will be 6. So now set this to be the same as this, and then so really a here is a here must be 3. So now we've got a, b, and c. So our quadratic will be given by this. Okay. So if you get a graph plotter, plot our original function, which will be this here, and then plot our quadratic approximation, which is this one here, and then it will give you this graph here. So the blue line is our approximation, the red line was our original function. Now looking at x near to 0, you can see that the blue line's a good approximation to the red line. Okay, so this here is our approximation.